As a warning, this experiment involves high temperatures and concentrated acids. Proper safety equipment must be worn at all times. Dilute acetic acid is commonly referred to as vinegar, whereas acetic acid which contains no water is referred to as glacial acetic acid. In chemistry, glacial acetic acid finds many uses as either a reactant or a solvent. You'll only need two chemicals, 50 grams of anhydrous sodium acetate and 75 milliliters of sulfuric acid. It is extremely important that the sodium acetate is anhydrous. If you only have access to sodium acetate trihydrate, you're going to first need to dry it in an oven. First, a round bottom flask was charged with 50 grams of anhydrous sodium acetate. Next, to an addition funnel, 75 milliliters of concentrated sulfuric acid was added. Before the addition, this is what the entire apparatus looked like. The stopcock is open and the sulfuric acid is added to the anhydrous sodium acetate. You should notice immediate bubbling and the production of white fumes. This reaction is extremely exothermic and it can produce enough heat to almost boil itself on its own. Once all the sulfuric acid has been added, turn the heat up a little. The reaction that is occurring is shown above. Sulfuric acid reacts with sodium acetate to produce acetic acid and sodium sulfate. And because acetic acid is a liquid and has a much lower boiling point than sulfuric acid, it is possible to distill it off. The addition funnel was removed and replaced with a thermometer, and the solution was brought to a boil. I collected everything that came over after about 115 degrees Celsius. Because the heat source was less than 200 degrees Celsius, the solution stopped boiling once all the glacial acetic acid had been distilled off. What remains in the flask is excess sulfuric acid and sodium sulfate salt, which both have a very high boiling point. The final yield of glacial acetic acid was about 35 milliliters. The product was quite pure with a density of about 1.052 grams a milliliter.